Hello everyone, the title of our paper is Understanding Action Recognition in Still Images. The goal of this work is to perform action recognition in still images and break down the action into smaller semantic components and then evaluate the importance of each of these components for the action recognition task. Video-based action recognition is a relatively well-established and well-studied area of research, whereas still image-based action recognition is comparatively less studied. Since motion cannot be estimated from a still image and spatio-temporal features cannot be used for characterizing action, action recognition in still images remains a challenging problem. For many action categories, a single frame is sufficient to accurately classify actions. This evidence supports the development of computational algorithms for automated action analysis and recognition in still images. Still image-based action recognition has many useful applications. It can be used for surveillance, robotic applications, searching for an image in a database using verbs, understanding the functionality of an object, etc. In this work, only actions that involve a person manipulating an object is considered. Since this study is focused only on actions that involve objects, a custom dataset with 8 classes is created. The custom dataset has 8 classes with 200 images in each class, and the dataset contains classes like drinking, fixing, phoning, pouring, reading, writing, and sitting. In this experiment, YOLO version 2 trained on MS COCO dataset is used to find regions of interest in the image. An action is broken down into 4 parts: human region, object region, interaction region, and the union region. YOLO is used to detect humans and objects in each image in the dataset. The custom dataset is carefully constructed to ensure only object categories in MS COCO dataset appear in the images. Only the bounding box coordinates are used in this experiment. Class label information is used to record if the object under consideration is a human or not. The reason is to understand what kind of object is used for a particular action. We are not interested in the object itself. The core idea is to generalize among different object categories, encode the common properties among them, and evaluate their importance in action recognition. Person and object bounding box coordinates are used to find the intersection region and the union region. Intersection region focuses on the parts of the object and person involved in the action, and it is the core of the action. Each of these components are presented using a 4096 dimensional vector, which are high-level features obtained from a pre-trained CNN. These 4096 dimensional vectors are concatenated to represent one image in the dataset. A classifier is trained on these concatenated features to perform action recognition. To specifically encode spatial relationships between pairs of action components, a custom feature is introduced. This custom interaction feature takes into account the relative area, distance, and angle between any two components. Here are the results from our experiment. It can be seen from these results that the combination of SC7 all components and custom relative feature with logistic regression gives the best classification accuracy of 81.97%. This result shows that the approach of breaking action components gives a better and more complete representation than looking at the action as a whole. Separating the action components and then processing them together increases the focus on each of the components while capturing their interdependencies and spatial relationships. This makes the model more robust to variations in the dataset, leading to better generalization. It is also seen that person is a better cue than object, and using CNN codes for representing interaction is better than the custom relationship feature. Another interesting observation is that using Conf5 activations for objects produces better results than using SC7 activations for objects. This shows that Conf5 features are able to generalize objects better. They are more robust to intra-class variation and better capture the kind of object that is needed to perform a particular action than FC7 object features. This slide shows the feature importance based on clustering. The trends and patterns are similar to classification results. These results bolster our hypothesis that action is made up of individual components, and treating them separately and then combining them makes the model more robust. Here are the key takeaways. Thank you.